So here, just kind of a little extra from the POGIL. I know the POGIL some of you struggle with. It does make you think. It does. The idea is that it does lead you to the right answer, but you're never really getting that kind of concrete. Okay, this is how we, this is how we do these type of problems. So this kind of supplement to that. Here, this is where you'll see, those concrete examples using those rules. So naming binary ionic compounds. This would be for something like NaCl. How you would name that. So instead of NaCl, first, again, it's the easiest type. So we have something that is just a standard representative element. It's not a transition. So you just name it. Then you name the anion, change the ending to "-ide", put them together in that order. So cation first, anion second. You get something like sodium chloride. It's the easiest type. Don't make it any harder than it needs to be. Something you need to do is figure out the different types and the sets of rules for those types. So you got to start kind of looking for those. Examples: NaBr, well, that would be sodium bromide if I change the ending. The next one, calcium chloride, and then aluminum fluoride. So didn't change the name here. They were all representative elements, so no transitions. So I said the name, changed the ending of the second one, you're good. So these transitions, how do we know the number of valence electrons? Well, we could kind of figure it out. What we really care about, though, is how do we figure out the charge for things like this. Really, what you need to know is, one, you can use the clues around these ions. So what's it bonded to? What does that thing have as a charge? And the other thing is, you're going to get a handout that has charges for these ions on it. So that will help you as well. So rules for naming compounds with transition metals. They're the exact same, except some of them you need to use a Roman numeral. Now don't go all crazy with the Roman numerals. Notice only some of these have Roman numerals. The ones before, sodium chloride, calcium bromide, things like that, don't have Roman numerals because they're not transitions. So we only use Roman numerals for transitions. Where's my slide? There it is. And not even that, we only use Roman numerals for certain transitions. The exceptions, so ones where we never will for the transitions, ones you're going to see a lot: Ag and Zn. Silver and zinc will never have Roman numerals. The rest of the ones I give you will. So lead, iron, nickel, mercury, tin, copper, those you will always use Roman numerals for. We just got to figure out what's the Roman numeral going to be. So this is where, again, like I said, you look for clues in the compound. Example. I'm going to switch out of my view here, make it easier to write. So the first one, FeCl3. Well, I'm looking. Fe is a transition metal, so I am got to double check. Go check my cheat sheet. Well, actually, how about this? It's not zinc and it's not silver. I'm going to use Roman numerals, is what it comes down to. So I got to figure out what those Roman numerals are going to be. So this is where I use my clues. My clue is chlorine. So Cl, where it's located on the periodic table, I know it always has a 1- charge. Except I have 3 of them. So total, I have a 3- charge. Which, again, to get this to equal 0, I need my iron to be a 3+. And I go and double check. There's only one of them, so that one iron has a 3+ charge. That's what I'm going to use to write my Roman numerals. This is iron 3 chloride. The next one, again, actually all of these, I have transition metals, but silver is one of those that doesn't have a Roman numeral after it. So I just need to write the name. So Ag, like we said, is silver. O is oxygen, but I got to change the ending to "-ide". The next one, titanium nitride. Well, it's a transition. It's not silver and it's not zinc, so it's going to have Roman numerals. I got to figure out what they're going to be. So I go to my clues. Well, my only clue is nitrogen, and based off its position on the periodic table, I know nitrogen has a 3- charge. The only thing is I have 4 of them, so that's a 12- total charge. Again, I want my total charge to be 0. So that means my titanium has to be a 12 positive. But I have 3 of them to make that 12 positive charge, so each of them has to be 12 divided by 3 is 4 plus. So I'm going to use this number for my Roman numerals, much like I used this number for my Roman numerals in iron. This is going to be titanium 4, and then nitrogen is going to become nitride. Next one, NiO, well, transition metal, Ni, nickel, and it's not silver and it's not zinc, so it has Roman numerals. So I got to use my clues here. Well, oxygen, based off its location on the periodic table, is always a 2-, and so total, I only have 1 of them, it's a 2-. To get that to equal 0, well, that would be a 2+. I only have 1 nickel, so 1 nickel is a 2+. I'm going to use that to write my Roman numerals. So this would be nickel 2 oxide, so oxygen to oxide. Next one, I see a transition metal. It isn't silver, it isn't zinc, or it is zinc, so it's one of those that doesn't. In this case, in this one, I would have zinc phosphide. No Roman numerals in this case. Last one, transition metal. It's not zinc, it's not silver, it has to have Roman numerals. Use my clues here. Clues, bromine is a -1. That must mean copper has to be a +1, so write it that way. COPPER, copper 1, bromide. And there will be a second video on how you do the opposite, how you write the formulas from the name, so use that as practice. Remember, only use Roman numerals for transitions, and not even all of the transitions, just the ones that aren't silver and zinc.